Andrew Webb from Texas A&M University. His talk will be wearable as context for Guiard-abiding Bimanual touch.
Thank you. So this is work I did as an intern at Microsoft Research with Michel, Pahud, Ken Hinckley, and Bill Buxton. So large multi-touch displays, such as the Microsoft Surface Hub pictured here, provide services for collaboration, enabling multiple users to interact simultaneously. The problem is that touch sensing on these large displays provides only generic contacts with no details about which touch belongs to which user, or further, which of a user's hands, left or right, made the touch. The combination of which user and what hand are important contextual details needed to truly support designing bimanual interactions that take full advantage of humans' abilities to coordinate roles of the hands in bimanual activity. To address this problem, we can leverage the growing number of interconnected devices that exist in collaborative spaces. As we work around large displays, such as digital whiteboards and tabletops, we often have smaller devices, such as laptops, tablets, and smartphones that provide personal displays for us to work. And then we even have smaller devices, such as smartwatches and fitness bands, that provide peripheral interaction and that can be used to sense human motion. These wearables also stay with the users as they move around a collaborative space, making them advantageous for sensing interactions across multiple surfaces, including large collaborative displays, as well as small personal devices. By augmenting touch with sensing from wearables, we can provide contextual details for interactions on large displays. We do this by associating surface contact forces sensed by wearables with touch input. So long as the hand is instrumented with a wearable, we can identify the user and the hand. The nice thing about this approach is that we know which specific person touched, not just some arbitrary user A or B. So I will show how using wearables on one or both hands supports phrasing together bimanual interactions in a manner consistent with human bimanual activity, in which the hands are assigned to different roles. Because of the limitations and ambiguities, most of the previous systems exploring bimanual touch have not been able to fully support assigning different roles to the hands. Instead, designers are often forced to rely on interchangeable roles for the hands, typically using symmetric mappings, or requiring mechanical intermediaries such as a pen to differentiate the hands. Even still, those systems that have supported identifying the hands and users have not considered principles of bimanual activity as set forth by Guiard in the design of interactions. Guiard derives a set of principles to describe bimanual asymmetric action based upon the roles of the hands. As opposed to manual superiority, where one hand is considered dominant to the other, Guiard introduces lateral preference, which frames bimanual activity in terms of the complementary roles of the hands. In this image here, the left hand holds the fabric while the right hand threads the needle. An alternative lateral preference would be for the right hand to hold the fabric and the left hand to thread the needle. Based upon lateral preference, Guiard identifies common methods of bimanual coordination among right-handed persons. In particular, we refer to two of Guiard's principles, right-to-left spatial reference and left-hand precedence. The principle of right-hand spatial reference states that the motion of the right hand typically finds its spatial reference in the results of the motion of the left. So here we have a fashion designer who is cutting fabric with a stencil. She's holding the stencil in her left hand, and this provides an outline for her to cut with a tool in her right hand. So the left hand holds the stencil in a steady state, while the right hand applies pressure and rolls the cutting tool to modify the fabric. The left-hand precedence principle states that the left hand tends to lead the right in its contribution to joint activity. So here this woodcarver uses his left hand to first place and hold a chisel where a carving needs to be made, then applies force to the chisel with the mallet in his right hand. Guiard's principles and observations focus on asymmetric activity. However, he does note that some actions, such as turning a steering wheel, involve symmetric roles. While this research also focuses on asymmetric interaction, we are not trying to portray asymmetric interaction as more valuable than symmetric, only that symmetric mappings use interchangeable roles for the hands, which can mask the inability to distinguish the hands in bimanual interaction design. In addition to Guiard's principles, we also apply Buxton's concept of phrasing in our bimanual interaction design. Buxton describes how using muscular tension to phrase together a series of inputs as a way to help users form higher-level abstractions for performing compound tasks. For example, selecting a command in a context menu with a mouse involves 3 subtasks. First, invoking the menu by depressing the mouse button. Next, navigating to the desired command by moving the mouse while still keeping the mouse button depressed. And then finally, selecting the command and returning by releasing the mouse button. So the release of muscular tension provides closure, returning us to a neutral state. As you will see examples of later, we phrase bimanual interactions such that the left hand initiates action and establishes a frame of reference. Then the left hand maintaining tension, with the left hand maintaining tension, the right hand can act with the reference frame performing operations. Lifting up the left hand releases the tension and closes the phrase, ending the task. So our investigation began by first building Affinity, an environment for authoring affinity diagrams. So affinity diagrams involve recording ideas on Post-it notes and organizing those notes into groups, and it may also involve sketching amidst those notes, as you can see in this picture here. So in Affinity, we instrumented one hand, the left with a Microsoft band. The user activates an in-place tool sheet with the left-hand touch and then selects a command such as adding a Post-it note using touches with the right hand. So here we can see a user, Michel, who's going to touch with his left hand to bring up the tool sheet and then tap to add 2 colored Post-it notes with his right hand. So here we have another user, Jacob, who has a different tool sheet, and he's going to select green ink and draw with the touch with his right hand, and then select a blue ink and draw. And so we can provide different contextual menus depending on which user, because we can uniquely identify them by their wearable. So in Affinity, we support Guiard-abiding touch by initiating an in-place tool sheet with a touch from the left hand and then selecting commands in the sheet with the right. In fact, we do not need a wearable on the right hand to support these asymmetric interactions, since we can use the left-hand precedence, Guiard's left-hand precedence principle, requiring left-hand touch to activate the tool sheet, then using the right-to-left spatial reference principle, defining right-hand interactions framed by the tool sheet activated with the left. So in terms of sensing, we identify the user's hands by detecting spikes in the accelerometer data of the wearable and associating those spikes with touch events. So we're looking for tall, narrow spikes representing a sudden change in force associated with the hand coming into contact with the multi-touch surface. If that spike falls within 100 milliseconds of a touch event, we associate that touch to the user wearing the spiking wearable. If a touch occurs without a spike, then Affinity considers that touch associated with the right hand of a user, but we don't know which user, and that's contextualized by them interacting with the tool sheet and their proximity to the left hand. So we further investigated how instrumenting both hands with wearables can support bimanual interaction on large displays. To do so, we developed Moodboard, an environment for authoring mood boards. Mood boards are assemblages of images, sketches, and visual media used in collaborative studio spaces as part of design processes for problem solving and problem finding. This allows for drawing connections among ideas through juxtaposition. Within mood boards, we developed, so in mood boards, the user can collect and organize visual media as well as sketch with the pen. We also developed a suite of interaction techniques to exemplify how to apply Guiard's principles to phrase together bimanual action. So we again instrument the left hand with the Microsoft band. We instrumented the right hand with an in-house design ring with an IMU. This reflects a more likely scenario in the real world than if we had instrumented both hands with the band. It also lets us explore any differences and issues when wearables are located on different positions around the hands. So by having both hands instrumented, we can distinguish both the left and the right hands of multiple users. The right hand is then able to function in isolation from the left, which was not the case with Affinity. However, it does add an additional wearable that the user must wear. We also leveraged additional sensing capabilities of wearables to detect different orientations of the left hand. The normal touch orientation with the palm down, side of the hand orientation with a chop gesture, and then a back of the fingernail gesture, which involves sort of pinching, as if pinching or holding a card in your hand and pressing it up against the screen. We choose these orientations because they provide representative mappings for the actions they perform, and they are distinct enough to recognize using simple sensing algorithms. So mood boards involve composing overlapping content within a 2D space. The first technique in mood board that I will discuss is Chop Z, a technique for layering overlapping content. Chop D begins with the chop gesture with the left hand. After the chop, the right hand then defines a selection. Defines a rectangular selection region, or by flicking, you can select everything to the right. Once we've defined a selection region, we then animate a transition as if looking at the selected space from the side. So we remap the x-axis to the z-axis so that the topmost element appears on the left closest to the chop. And then elements can then be dragged with the right hand to change their z value. So here's a video chop, a swipe to select everything. Now we're looking at it from the side. Here I'm moving something lowered further back and then bringing a couple things up near the top. And then I release my left hand and it transitions back. So a straight edge is a valuable tool in visual design. We developed a technique for using a straight edge to constrain input of the right hand to follow along a guideline. So we do that with a two-finger gesture where the left hand activates and phrases the straight edge tool. A guideline appears with the slope matching the line defined by the two touch points. So then when the user can then, with a pen, draw a straight line. However, with touch, the user can move a single element along that line or an entire region to the right of that line. The ability to create groups is important for organizing overlapping content in a mood board. Group sheets is a technique for explicitly defining groups. It begins with and is phrased via a three-finger right-angled gesture with the left hand which then presents a sheet where that hand defines the bottom left corner of the sheet. The right hand with either pen or touch can mark elements to add them to the sheet. Then lifting the left hand closes the phrase, ending the technique, and adding the group sheet to the mood board. So here we'll see defining the sheet, and then with my right hand, I'm marking the elements to add. And then you can move it around. Here I'll create another group sheet, and one of the things to note about group sheets is that you can actually include elements in multiple group sheets. So here I'm going to add the grow image, so now it's in both sheets, and so it acts as an anchor for the two group sheets. So if I move the sheet without touching the grow element, then it moves just the elements in that the red group sheet, but then when I touch grow, it moves the two sheets together. We also have a tool sheet, just like from Affinity, except for Moodboard, the tool sheet is for specifying the style of ink. And we use the back of the fingernail pinch gesture I was talking about, so it's as if you're holding that tool sheet up to the display, and then you can use your pen to select different colors as well as thickness of your ink. Beyond bimanual interactions, we also supported unimanual interactions for moving around elements, where the right hand moves an individual element, while the left hand will move piles of overlapping content. We can also use ink to help connect piles, allowing you to move multiple piles together. So we conducted a preliminary evaluation of Moodboard involving 8 participants. The evaluation consisted of a series of walkthroughs for each technique, where the participants were shown how to perform the technique, then asked to perform it a number of times, then answer a brief questionnaire about each technique. After walking through all the techniques, participants were asked to author a mood board using any or all techniques. This gave us a sense of how the techniques work together and which ones participants favored for actually creating a mood board. And here are some examples of some of the mood boards that participants created. So a couple of things that we found. In terms of CHOP-Z, they felt that it was easy to use and they liked being able to select a region. One of the issues, though, was that some of the participants reported was fatigue in maintaining the gesture, and so this is sort of one of the issues with using tension to phrase interactions, is that we have to be very careful about what gestures we choose in terms of maintaining that phrasing. In terms of the straight edge tool, participants found it was easy to use, and they actually had no problems understanding the differences between using the pen to draw a line versus using touch to move elements along the guideline. Some participants did get confused about which hand to use for the unimanual positioning, but they felt that with practice that they would get used to it. Also, we suspect that factors related to ergonomics and effort are more present on large displays, so that I may actually need to grab a group of elements that are up near the top right, but ergonomically I want to use my right hand to do it, but I have to use my left. So that's kind of the issues with that. So in concluding, wearables provide context for identifying both users and hands on large multi-touch displays. They are personally identifiable, meaning that the interactions can be tailored uniquely to each user. Since wearables enable identifying a specific person, we can recognize novice users versus experienced users and help novice users learn gestural interactions for a system through self-revelation, such as employing feed-forward techniques to guide these users. We can then scaffold that training as the user becomes more experienced. While the focus of our investigation was on designing asymmetric interactions, our goal is not to favor asymmetric over symmetric. We seek to make accessible a multitude of appropriate and consistent mappings, including both asymmetric and symmetric, but also intermixing of the two, which is afforded by the additional context of wearables. While we apply Guiard's principles to strict hand assignments, we are not arguing that this is always the appropriate approach, only that by providing an additional context, it replaces the choice of lateral preference on the interaction designer rather than on the underlying sensing capabilities. Our objective is to motivate new considerations in bimanual interaction design. And so with that, I conclude my talk, and I'll take questions, comments, and suggestions.
Thank you, Andrew. Questions?
Thank you. I had a couple of questions, actually, but the first one was, how do you distinguish the gestures? I missed that point.
I'm sorry?
How do you distinguish the gestures? How do you distinguish this from the pinch, for instance?
Right. So in this case, we are just using. There's a 2-finger gesture, a 3-finger gesture. And then we're also using the orientation. So we're combining the combination of the number of touch contacts and their positions with the orientation of the wearable.
Okay, and how do you distinguish the pinch one?
The pinch one is so the orientations are all determined by gravitational forces, looking at the band and how it's so because you have your wrist rotated to do the pinch one. It's not like a normal touch. Your wrist is going to be.
And you're able to disambiguate just with accelerometer between the chop and the pinch?
Yes.
Okay.
Yes.
And why do you use the 2 wearables? I understood the armband is for identifying and the ring is for identifying the hand, user versus hand?
So we wanted to look at, by putting 2 wearables, both wearables are for identifying which hand. The thing about having the ring, the addition of the ring, is that it allows us to know, distinctly know that was a right-handed touch. Otherwise, when we don't distinctly know not just that was a right-handed touch, but which user was giving that touch, so that then users can use their right hand to do unique things that are specific to them.
Because there are only two hands, so right. I guess one identifies the user and the other one identifies the hand. Otherwise, you won't need one.
I mean, so you still need, if in the case of Affinity, where I just had the band, if I touch with the right hand without the context of the left hand, I don't know which multiple users can touch with the right hand, but we don't know. I don't know to use what like in the case of doing the ink, like I don't know. We don't know if one user is drawing with red ink and one is drawing with blue ink. If you just start putting your right hand up there, we don't know which user you are. So we need you to first touch with your left hand. But if we had the ring, and then you selected the ink, then you could potentially not have then you could just use your touch with your right hand, and that would we would be able to like the whole having the ring allows us to distinguish both the hand and the user, isolated from the other hand.
Okay. Thanks.
Other questions?
Hi, Michel Lafont, Université Paris-Sud. Very nice work. In the beginning, you talked about the society of devices, but I noticed here on the work you were using a single surface for interaction. So, and I also noticed that some of the motivation and observations from Guiard are using tools to interact with things like chisel or things like this. So, how do you see this extended, where you use both additional devices like smartphones or tablets to support this sort of a tool-based interaction?
Yeah, that's an interesting question. So I think so yeah, I do think that well, for one thing, one of the things we did want to look at was the potential of using mobile devices as an alternate form of sensing, potentially, so that if you didn't have a wearable, everyone has a phone. That's one way in which, but also, I think too the idea that you can. Also then being able to support these kinds of interactions also with the wearable on, say like a tablet or something, where you also want to continue to use this kind of bimanual Guiard-abiding touch. It translates across devices, so you could use it. I could have whatever, multiple surface hubs or whatever, multiple tablets, and I could still do these same interactions across all these devices.
Thank you.
Okay, thanks.